Hello YouTube, RJ. Good news. PCBWay came through with our PCB boards for our AR488 project. So we got the controller and the interface PCBs right here. I'm sure as always, PCBWay did a good job for me. Not sponsored by them. I'm actually not sponsored by anybody. I have actually absolutely no sponsors. Everything you see me buy, I pay for myself. So let's take a look at these PCBs and see how they came out. So let's open up the controller and take a look. Now, once we get these built, make sure everything's working, I'm going to design, CAD out a case for the controller and kind of a case for the interface, just a kind of a plastic piece that pops on them and shields all the contacts from anything shorting out or anything. So that'll be a continuation of this project. Here we go. Let's take a look at what we got. That looks nice. Got the link, got the little linky on there. Links Electronics Lab. Got my mount holes. Connector other side. Shows the connector on this side. Tells you which side to put the notch. That's very nice. So we're going to be building one of those. And then we've got the interface boards. So we're going to be doing that. We're going to be building two of the interfaces. Now I will only on camera build one of them. I'll build one of these, but I'll be building two because I've got two instruments I want to connect. Now, this is going to be pretty straightforward. These are not going to be difficult builds at all. I got all my parts laid up here to get started in doing this. So let me pull some parts out and show you some things. First of all, the Arduino Nano that we're going to be using, I'm stuck down in there a little bit. I'm going to be putting some sockets on for that. And I think I'm going to kit up some of these and put them in the store for the boards I have for anybody that comes along and needs the same thing to make their life easy. What I'm going to do is, because I've had to buy like chips at 10 at a time to get a reasonable price and such, and boards, of course, 10 at a time. So, you know, I can make it available a lot cheaper than you can turn around and have new boards made and order individual chips. Yeah, in run, that's what we're going to do. These are going to go in the store, the extras. So we're going to start, I think I'm going to start with the interface. Or I'm going to start with, let's start with the controller, because I'm going to do two interfaces in a row. I'm only going to film one. But I'm going to put sockets on the board for the Nano. And the reason I'm going to do that is I'm going to put sockets for everything. And the reason I'm going to do that, you know, and I've done this, it's not just a rookie mistake, put chip in backwards and soldered it in and realize, oh my God, I put it in backwards. I got to get it back off of there. The nice thing with sockets is I can take sockets and throw on this board. These sockets cost cents. I mean, they're so cheap, it's ridiculous. I can throw these sockets on there, solder, and not worry about overheating a component or damaging anything. Get them on there, push the chip in. I know the chip hasn't been damaged. And ooh, I put it in backwards, pop the chip out, turn around, put it in. Oh, I got a problem on my board. I think that chip might be bad. Well, guess what? We could swap the chip out and see if that's the problem. And in the lighting controllers, because I had so many people building those things, you know, it can save people. So I'm going to go ahead and build it with this, and the kit will include sockets. So you'll solder the sockets all on the board, and then you'll plug the parts in. The other thing is you got to program the Nano, and if there's something wrong with the programming, yes, you can program it on the board, but you know, if you need, you can pull it out. That's also going to help out within the kits. I will go ahead and program the Nano for you. And you can program it yourself if you want to again. But for those that, you know, don't have the feel for programming or never done that, or that's kind of the holdup, they're really not a microcontroller person, it makes it open and available to them because it's already programmed. You just they pop it in the socket, boom, Bob's your uncle, you're ready to go. So the first thing we're going to have to do is we're going to have to get pins put on our Nano. Since they come, we don't need the ISP programming socket, but we need these on our Nano. So let me get it on the right side. So we need to make sure that we get it on the right side. Make sure your USB is facing up away. We're going to put these on, and there's a couple little challenges with that, and that is trying to make sure these legs are parallel. They're not in or out, or, you know, everything is straight. And so one of the ways we could do that is if we went ahead and plugged in to our board. Note the board is marked USB. The USB jack needs to face that direction. Let's go ahead and do it this way. We're going to plug this stuff all together on the board. And what that's going to do for us is that's going to make sure everything gets lined up and straight, and will go in the board. So we're going to do that. We're going to lay it up, and we're going to go ahead, get our soldering iron and get one of these pins tacked in on each corner so that we can make sure that things get the way we need them to be. I'm going to bring my fan out. I'm sorry about that. I don't like to breathe all these fumes. I've breathed enough of them over the years that I'd like to avoid as much as possible to breathe any more of them in. Let me get this fan going. Hopefully it won't affect the audio too much for you. Let's push down solid and get this tacked in. And I'm just going to go ahead and do all 4 corners. Now, the other nice thing about using the sockets on this Arduino Nano is that the pins on this are very long. You saw when, take one of these out. See how long the pins are on that? See how much it would go through the board? Well, we're going to have our connector sticking up on this side of the board, and we want to bring it up close to the case so that this sticks out. So that keeps it, also makes these short. So everything's going to be short. That's going to be really nice. Now that that's tacked in like that, I know that I can go ahead and solder that, and it's pointing straight up and down, and I'll be able to get the chip in later. So what I'm going to do is I'll get this down a little here. I'll go ahead and solder this in a rapid succession, and you'll get the time lapse that. I'll be right back with you. Okay, first step complete. Now what we can do is go ahead and put our sockets on the board. Now when you look at these sockets, you're going to notice there's a little notch in the front. That's your pin 1 indicator. Okay, and if you look on the board, you're going to see little white dots right here. Hopefully you can see that well, indicating pin 1. Make sure your notch is facing to the pin 1 side, so that my white dot's on this end of the chip, so my notch goes that way, and that way I can see from the socket which way the chip goes in. And let's see, we're gonna fight to get the pin started, because there's always going to be one or two that's been a little not straight. There we go. Now, same here on this board. Notice they're opposite. The chips are turned opposite of each other. Make sure you get them in the right way. Now, normally I do the shorter stuff. I did this because I was talking about the Arduino and trying to get everything, but as long as I can keep that up and get it tacked in, it doesn't matter. So let's go ahead and tack a couple pins on each one of these, and then we'll be ready to solder them. Now, before I go any farther, let's make sure our sockets are sitting down. If they're not sitting down, heat your solder joints up, push them in, but they're looking good. So now, enjoy a little more music while I solder all these connectors. Okay, always look over your joints real well. Make sure you're happy with them and you haven't missed any of them. All this is looking good. All we need is a little cleaning there when we're done. Okay, at this point, what I want to do is I'm going to go ahead and put my ribbon cable connector on. Now, it goes on the bottom, not on the top. That's why I've got connector other side to make sure, because I knew I would forget. So, not just because I think you guys will mess up, it's because I know I will. I would get in a hurry, pop this on. This keeps me from doing that. You've got a little notch mark there. It says notch size. So you've got the notch of your connector. So make sure you get the right one in the right place. Now, we again got to tack this in somehow or another, keep this in. So we want to make sure we hold it up a little. You just got to get 1 or 2 tacked in flush. So let me push the board down flush and hit a couple corners here. Okay, now I'm ready to solder them all in. So let's just knock them out. I'll turn it this way, a little easier for me to see. Okay, everything looks good there. So here's what we're ready to do. We're ready to get our nano soldered. So we put our ends in. Make sure you get your USB pointing that way and the chips and everything facing up. Put it on and go to town soldering it. Okay, I'm not going to put that on because we won't be using this to program this. We'll be using the USB, so I'm not going to stick that header on. So give that a minute to cool down a little bit. We're ready to do an interface. Fan's going to take a minute to cool off and shut down. Interface is just 2 of these, 2 of those, and 1 of our AR488 ports. Everything goes on the top of this ball. Just make sure your notches are facing the right way. Do the shorter ones first. Make sure when you're looking at this board, there's the notch. Make sure the notch goes that way. Get these in. So I'm going to try to put 2 in the board at the same time and lay it on them to hold them down flat. All right. Okay, that looks pretty good. So we just need to pop our GPIB connector on here, RS488. And let's see if we can get her in there. And of course, like anything with these fine little pins, they're never perfectly straight, and you're always fighting to get them in. And you also have with this, you've got some little snaps that snap into holes. So you got to be careful you're not pushing to do that and bending pins at the same time. So take your time. Everything line up. There we go. All right. She'll snap on like that. Nice part of this, you don't have to worry about getting it straight or anything, because as you can see, it snaps on. These little snaps pop through the board and snap when you get it on. So now I just need to solder these. And just that straightforward, the interface part's done. So now what I'm going to do is, off camera, I'm going to build another one of these real quick. I'll throw all of this into the ultrasonic cleaner off camera and bring it back nice and clean, and we'll be ready to next step, and that is program the Arduino. I'll walk you through that. There's some code that has to be changed in the configuration files depending on what you're using and what you're doing and a few things. So we'll go ahead and configure that. We'll program this Arduino. We'll make sure it's working, and we will pretty much be ready to give this thing a test. Okay, so I'm back. I cleaned these up, had a little dinner. I've got 2 interface boards done and all cleaned up, looking good. I've got my controller ready to go. Need to put some chips in. I'm going to put the 160. If you look down in close right here, you can see there's text through the window. You can actually, I put a silk screen there where you can see which chip was which, even with the socket on. So pull your chip out. I put my static strap on. Make sure you look at the socket, see the notch. Okay, see the little dots, number 1. Find the notch on the chip right here and make sure it's facing the right way. Make sure to get one side of your pins lined up and in. Tilt it down. Make sure you get these pins all lined up. What you have to do is put in one side and then push just a little bit, because the pins are designed to spring. They're out a little bit, and so they spring out in the socket. So what you want to do is you put one side in, then you push against it to get these started in. Take your time, make sure all your pins are looking good. Make sure everything looks straight. I got a pin that's a little out here on this one. I'm going to straighten. Make sure you're putting it in the right direction. Set it in, drop it in. Push to the side a little as you start this side. And then push it in. And that's all there is to it. Now, we're going to do the same thing with our 161 chips. Grab me one of those. Find the notch on my notch and the little white dot on pin 1, and the notch is on that end. Notch on this is there. Put the pins in and get them lined up on the one side. Well, push over a little and ease it down in there. Make sure all your pins are lined up and looking good, and then just give her a little push till she drops in the socket. And there you go. You're in business. Now what I'm going to do, I'm going to jump over to the computer. I'm going to pull up and we're going to talk about the software. We're going to show you about the configuration settings. We're going to hook this thing up, see if we can program it, see if it responds. And then at that point, we'll be ready to set up a meter and maybe give this thing a test. So, okay, here we are. I have downloaded this AR488 master.zip file. That's the whole project from GitHub. I'll put a link in the description. If you're getting a kit from me that has an Arduino with it, it's already programmed. You wouldn't need to do this unless you just wanted to make changes or play around, but it's going to be already configured, ready to go. So the first thing we need to do is extract this. I'm going to extract this right in this folder, and it's going to pop up the new folder it created. And so we have the manual here. So let me open the manual. Let's pop over here and look at the manual. This is the manual for it. It's very good documentation. As you can see, it covers a lot. This comes in important because this project is designed around a whole bunch of different processors and such. And so you have to configure the software for what you're doing. So what we're going to do is we're going to go into source. We're going to go into AR488, not the ESP version. We're going to go in here. And we're going to open up the sketch. So there you go. No, I don't want any updates at the moment. So we get in here and you start, let's go back over the manual, and you start in the manual and you start down, and it talks a lot about the project stuff start off in the manual. But we're going to dive down to page 13 because that's where configuration starts. And it's going to explain to you that there is a file, AR488 _config.h, that is pulled into the project. So let's go back to the project. Let's find that file up here. Let's open it. And it's going to explain to you that you've got to do a bunch of configuration. So let's go back to the manual. We go down and it talks about where all of these things are defined. It talks about defining custom boards and then deciding what boards you're going to use and configuring it. In our case, we're going to use the Nano. So the first thing we want to do is go down and find the code like this. So let's go back over here and look for that. We come down. Yeah, I'm already down at the top. Start down, and here's the custom board. Don't want that. Here's the ATmega 328P and the 328PB, and those are going to be the chips on the Arduinos that we're working with. And we get down and we see that this one, if it's this processor, it's set up for the Uno. We don't want that. So what we're going to do is we're going to comment that out. And we're going to uncomment out the Nano. We're going to go down to the 328PB, and just in case we're using a board with that, we want to make sure that the Nano's uncommented, which it is there. And so with that, the project now knows what controller we're using. So let's go back to the manual. Let's scroll down a little bit. We're going to get into serial port configuration. We shouldn't have to change anything here. All the speeds and everything are fine where they're at. We're not going to do Bluetooth or run the debug serial port, so we can skip those. We can go down. We're not using macros. We can ignore that. Keep going down. Keep going down. Oh, wait a minute. Here's where it talks about using the 75, 160, 161 transceivers. This project can operate without them, but there's a lot of little quirks when you do that. You have issues with power coming back in and trying to power the processor when you turn it off and corrupting the memory. There's issues with not enough drive to drive a bunch of devices on the bus. So we're using these. We've got the two chips we put on the controller. So you have to tell the system. And you go down and you find this part. So we're going to jump over here and start scrolling down again. And here we are. And because we're going to use these chips, we need to uncomment the define statement there. And then we need to look at the pins. And in the case of ours, we have pin 6 as the TE, so we're going to uncomment that. We have pin 13 as the DC, so we're going to uncomment that. And then it's got TE and DC here. We don't want those defined. We're going to comment those out. So now it knows to use that we're using these chips and that the T's on pin 6 and the DC's on pin 13. And so that should make us work. And then the rest of this is all, you know, rewiring, remapping out pins if you want to change, and macros and stuff. So we're done. That's the configuration. So now what we do is I've plugged my Nano in and it's created a COM port 12. So we go up here and we're using port 12. It's an Arduino Nano, that's correct. One thing you may run into is with these Nanos, if you have trouble where it just hangs and doesn't, it compiles and hangs and doesn't load on the code into the chip, go down to your processor. If it's on old bootloader and you have the newer bootloader, it won't work, and vice versa. So if whatever this is on, swap it and try again. This was set to old bootloader, and the Arduinos that I got have the newer bootloader, and it wouldn't work. So anyway, at this point we should be able to check our code. It says it's compiling the sketch, completed, no problem. So now we're going to load this code into our chip. So hit this, it's going to load. We're done, and we're going to test it. We can go to the serial monitor. If everything is working, we should be able to send a ++ VER to the board and get back a string with its version and everything. And we did. It returned AR488 GPIB controller version 0.53.18 57225, just what we expected. In fact, it's from this string right here is where it's getting it. So we're up and running. We're ready to plug everything in, hook up a meter, see if we can do some stuff. Let me jump off of here, go over, we'll hook this up on the bench. Okay, pop my 2 new meters on the bench that both have RS488 or IEEE 488. And if you can look over here, you can see our controller, and we're connected up ribbon cable to the bottom interface, and then we are daisy chained up to this one on the interface. And while we don't have our little cases and covers made yet, we're hooked up and we've got our meters running. Over here, if you see, I've got my power supply feeding about 1 volt into this thing, and I've got the external, my little reference oscillator. Yeah, you can't probably see it, little black box. Yeah, you can, just right here. I've got it feeding in channel 1 here, and as you can see, I calibrated the thing about 4 days ago with this. It's been pretty dead on. I mean, it's dead on. I'm feeding external GPSDO into here. So we're running off of, look right here, we're external reference. So we know that the reference dead on. That little box, that's that little $10 reference that I used for the last year or so. I think it's a lot more accurate than I would have ever believed. I mean, after 4 days, it's sitting right at 10 meg. And I'm talking about 10 meg going down to tens of millihertz. So we're talking it's right on. Anyway, that's not what we're here for. 1 volt in here, 10 megs going in here. Got this hooked up. I'm going to jump over on the computer, and I'm going to fire up PuTTY terminal, and we're going to connect to our COM port for this thing, and we're going to try sending some commands and see if we can manipulate. So, okay, here we are on the computer. I'm going to go ahead and fire up PuTTY, and I have a connection set up for that. And so we should be hooked, and we ought to be able to test. Let's send a ++ version command. All right, we're talking to our controller. Now, first thing we need to do is pick an address, ADDR. Let's go to my meter. My meter is on address 2. Okay, so I should be addressing now my meter. So if I was to do, for example, a star, the old star IDN question mark, look at that, 34401. Fantastic. So let's do this. Let's try addressing my 5330131A. So he's on address 3. I changed them. I put them 2 and 3. So now I should be able to do a star IDN question mark. Come on, baby, work for me. Oh, look at that, man. We're talking to both instruments. So we've got our controllers working, our interfaces working, and I really should be able to measure. Let's see, we're on the 53131 frequency. So if I was to send a MEAS measure frequency question mark, and then I need to do @1 for channel 1. Remember, there's 3 channels, and you got to tell it which one. Fantastic. 10 megs on the money. 1.0 plus 007. So yeah, move the display. Yep, 10 meg right on the money. Okay. Let's say we want to go back to my meter address 2, and let's say we want to measure with it. I can just do a measure question mark with it, I'm pretty sure. Yep, just over 1 volt. Look at that. Hey, this thing's working fantastic. So I've got a controller. I can write software to it now, program it. I couldn't be happier. This project's working fantastic. And one more step we're going to do is I'm going to, in the next video for this series, the AR488, I'm going to CAD design a case for the controller. I'm going to CAD design a little clip-on cover that covers the bottom of the board on the interface so nothing can short the pins on the bottom. That will finish up this project. Hey, I'm very, very happy. This has turned out very, very well for me. And if anybody would like a kit of this, I will put a couple up there. If they sell, I'll get a couple more nanos and put the rest together. And but I've only got a few boards. Hey guys, I appreciate you hanging out with me. I really hope to see you in the next video.